In this present video, we're going to talk about the animation of mechanisms by using the animation of points that form those mechanisms. And so we're going to start by opening our worksheet. The first mechanism that we're going to animate consists of a wheel that rotates about point C, and it has a bar attached to point A, which is also attached to this point B, in which a piston moves in the horizontal direction. The dimensions of the mechanisms are the radius of the wheel is D and the length of the bar AB is L. And so we have a triangle here ABC that we can illustrate this way, which would allow us to calculate the position XA as simply as D cosine theta, and the position of XB as XA plus L cosine phi, phi being the angle right here. And so using the law of sines, we have this relationship that allows us to calculate the angle phi as in this way. And then we have our equation for XA and YA, the positions of point A. And for, as I mentioned, for XB is XA plus L cosine theta, and YB is always equal to 0 because the point B moves along the x-axis. And so I have this definition of my distances, and I have a function f of theta that will calculate the position of XA, YA, the angle phi, and the position XB, and then YB is equal to 0. With that, we're going to produce a matrix with the points Xi and YX and YI, XB and YB. And then we also have these matrices that indicate the bars that join point the 0, 0 with XA and YA, and XA and YA with XB, YB. We also produce a background. This is basically the circle with a size of 180, which is white, and a size of 200, which is blue. But the white goes on top, and you end up with these 2 points, the first 2 points, you produce a wheel. And then the plus sign is just the center of the circle. This matrix represents the path in which point B moves. And so with that, we're able to produce these animation where this is point B, this is our piston, and this is the wheel that produces the motion. If I remove the axis and the grid as in here, you get the mechanism purely moving around here. The second mechanism that we're going to illustrate for animation is this one, which consists of a point A that moves horizontally and a point B that moves vertically, attached by bar AB. We're going to describe this motion as a function of this angle theta. That will make XA equal L cosine theta, whereas YA is equal to 0. On the other hand, XB is always to 0, but YB is equals L sine theta. So we're going to let L be phi, the starting value of the angle theta be 0, the ending value to pi, and the increment pi over 20. We produce this vector that controls the animation, and this function that produces the value of XA and YB. Now, in order to follow the coordinate system here, the XA that I put when the angle theta is from 0 to pi in this situation, it's got to be negative. That's what I put that minus sign in there. Whereas YB is positive. Then I'm going to put an index, which is simply the result of dividing theta by the increment. So it's going to be a finite number of increments. And I'm going to produce this matrix that shows the position of point A as a dot, size 20, red color, and the position of point B as a dot, size 20, blue color. And then a position minus 8, 4. I'm going to produce a string that says K, eval the number to string K. So it's going to show the index here at any time. This is going to be a size 10, and it's going to be colored black. Then also we're going to produce this matrix that joins position A or point A to point B. This will animate the mechanism. This is a series of matrices that produces the path, and this is a fixed value that produces the path in the graph. And so the result is shown in here. So this B represents all those paths, those lines that form the cross, and then there's point A, which is the red one, and point B, which is the blue one, joined by the bar. And that's how you produce this animation of this mechanism. There's a couple of links here for animations that are available in the ASMAT Studio forum. However, I've created a video that shows you how to get there by following their Google location of my math forum, of the ASMAT Studio forum, sorry. And so you don't really need to copy these and type them. You can just go to that video, the next one of this series, and that will show you how to get to those animated mechanisms available in the forum, which have been provided by other authors. I will, at this point, end this particular video.